One of my students asked me a very fundamental question on my network training course about an important concept called the client-server architecture. That was the lesson, the client-server architecture. Part of me started to dismiss that question as too simple or too fundamental to answer. But then I realized, that is it really simple? So I started thinking about that. And they have very, very valid questions. What is a client? What is a server? And I was like, my question was like, what is really a client? Why do we have a client and a server? Like, although I talk about why, the whyness of it, because we built those things. Fundamentally, we know why. Everything eventually used to be in one machine. But then the processes used to eat each other up from the resources perspective. And we couldn't afford to give BV mainframe machines to every terminal user. So we created this thin client, and then we have the actual server that does the work. And then these thin machines will send the request to a server to process the actual compute. So we broke it. And then now the protocol between the client and server evolved over time. We have so many protocols, but eventually it used to be a function call. Just, hey, boom, call a method, jump to that stack, but now it turns into a network call. But we were okay with that latency because once that request made it to the server, the churning will happen there. And then the server might call other servers, and that's fine. They are all very localized. Everything is localized. The database is localized, and localized in a sense that it's closer, right? The server is closer to the database, and everything can happen there. But then even if I have a client in somewhere in Australia, and then the furthest server in, I'm trying to think, America maybe, right? Think about the greatest distance in the world, right? Even if that, the request will take time to travel. The thinner you make the request, the faster it will travel. So even if you have like a 1 kilobyte request, it will take like, I don't know, a second, let's say, worst case scenario, but it will reach there. And the process will take fractions of a second to complete because it reached there. And then the response, it depends. If the response was tiny, then we're downloading that. So that's the trip. So even if you have a far away client from a server, you can still have a performant application if you designed your backend in a way that it produces smaller responses. You take advantage of the client to maybe decompress large results. So you send fewer and fewer bytes. And if you build your application in a way such that it produces smaller payloads, then you can have amazing latency regardless of what. So that's why we built it, the client and the server architecture. But then what is really a client if you think about it? A client, it could be thought of as one process, multiple processes, a pool of threads. It's really a program. Even if you think about a collection of programs, it doesn't have to be one program. That program, when you spin up, it can spin up one process, which then forks another process to help it do other thing. And then it can create a thread pool or can create a process pool. And it will just do all of that stuff, right? Because if it churns whatever it churns. So this collection of processes and threads generated by the program's 1 or second, that's what we call the client. So we describe that. And then we have the same thing happening on the server side. The program has other programs it calls, which will spin up processes, which have spin up threads. And this collection is called the server. So we talk about this logically. And then, can I bring them back together? Of course. Nothing's stopping you. And people do that all the time. You can bring this together in one machine. it's no longer a client server. Well, it is. Logically, your client and server has happened to be in the same machine, but the networking stack is now the loopback. So now, if anything, people started doing this in recent days because like, hey, my client and server is just they're so resourceful. I have resources, so I can put the server and the client on one machine. It's okay. So people would started doing that, but then they forgot that they had this abstraction layer of protocols. And then we're taking the hit of the protocol. So things got technically slower than the original design if it was an actual method call. So we went back. You could do the client and server on the same machine, but you have to think about using a lighter weight communication like Unix pipes, for example, instead of the TCP/IP stack, even loopback. Right? You don't need that stack, but it's harder to do that if you didn't implement the client-server architecture in a way that can be put in the same machine. So yes, the answer to that question: can I put a client? What is a client? It's this collection of processes. What is a server? It's a collection of this process. Can I put them in the same machine? Absolutely. The idea is not that they have to be physically separated. The idea is they have to be logically separated. And then, yeah, you can put them in the same machine on one caveat, that there might be a cost to that. So just be aware of that. And this collection is what we draw on the board. This is my architecture. It doesn't have to be one process. It can be thousands of processes. But that is my baseline to what a client is and what a server is. And there is a communication between them. You can bring them as close as possible if you need to. But if you do, make sure that you also create a layer that those two can communicate as fast as possible without the TCP/IP stack that you created in the first place to enable the client-server communication. So that was, I thought, something, just one question that I was about to dismiss generated all those thoughts to me, and I thought I'd make it into a video. If you're interested in this stuff, check out my fundamentals training courses over here or in the description. I'll see you in the next one. Stay sharp, everyone.